Okay, last graph we're going to look at, is the tangent function. So, how do we graph the tangent function? Well, how does the tangent function relate to the values on the unit circle? So, do you remember? Anyone? Hello? Tangent of theta is y over x from the unit circle. So, if we plot some points from the unit circle on a graph, what is it going to look like? I want you to try and do that. So, pause the video, plot points for tangent at the values that I've labeled. Notice the hint down here. Think about other angles, plot those as well, but there will be asymptotes. So pause the video, plot some points and asymptotes. Unpause when you're ready to check and discuss. Alright, so here's the general shape of what our graph should look like. Now, we'll talk in a minute about what a period is for tangent, because it's a little bit different than the sine and the cosine function. But I know tangent of 0 is 0 from the unit circle. Tangent of pi fourths is 1. Tangent of pi halves does not exist. That's a vertical asymptote. What is a vertical asymptote? Remember, a vertical asymptote, you can think of it as an imaginary line that a function will get infinitely close to and approach but never cross. So in this case, that's what's happening to the left of the asymptote here. This curve is going to continue on and get really close. Oh, that was a bad drawing. Continue on and get really close but never cross that asymptote. And then to the right of the curve, it's going to do the same thing, but now it's going down. So these arrows, they're never going to go straight down. They will get infinitely close to it. So they will continue to get infinitely close to the asymptote, but they will never cross the asymptote. Okay, then at 3 pi fourths, tangent is -1. At pi, it's 0. At 5 pi fourths, it's 1. So you have kind of a curve. My graph is not very smooth. So it does not look very nice, but we will see. Hopefully you get a general idea of what this curve actually looks like. Yeah, if not, you can see pictures of it in a book. Here at 3 pi halves, then we have another vertical asymptote. 7 pi fourths is -1, 2 pi is 0, and this pattern will again continue. So just like the sine and cosine, this goes on forever. We only drew from 0 to 2 pi because we were talking about the unit circle. You could have also plotted other values from tangent. So from the unit circle we get √3 and we get √3 over 3. Those are irrational numbers though, so they're going to be decimal approximations. So let's recap some vocabulary. The period is the distance of one complete cycle. Again, very important we understand it's a distance. That's why that's already underlined, but I'll do it again. And we're talking about one complete cycle, which is going to be different for the tangent graph than it was for the sine and cosine graphs. So where is a complete cycle on the graph that you created? So look back at this graph. Think about, where do you see a complete cycle? So write down what you think. Pause the video, unpause after you've written down. Okay, well on the graph that we drew just a second ago, a complete cycle was from pi halves to 3 pi halves. So this picture in here, that is the image of a complete cycle of the tangent curve. But this isn't the actual domain that we want to discuss for a complete cycle of the tangent curve. It does exist. It is a complete cycle. But now we need to think about what were the domain and range of the arctan function. So pause the video and write those down. See if you remember. Well, you may or may not remember. The domain of the arctan function was -∞ to infinity, and the range was -pi halves to pi halves. Not including the -pi halves and pi halves, but that's because at those values are asymptotes. So they are not actual outputs. How does the domain and range of a function relate to its inverse? So I want you to pause the video and see if you can write down or remember how the domain and range of a function relates to its inverse. Well, the relationship is the domain of f is the range of f inverse, and the range of f is the domain of f inverse. Okay, why are we talking about inverses? We did that back in Unit 2. This is Unit 4. I thought I didn't have to know that stuff anymore. Well, not exactly. So when we look at this, just like with the sine and the cosine function, the tangent function goes on forever. It's going to have these periods, so what I have boxed in the purple, that is one complete cycle or one period. However, this isn't where we want to say that it starts. The reason why is because we want to relate this to the arctan function. And the arctan has a range of negative pi halves to pi halves, so for tangent, we want to be focusing on negative pi halves to pi halves. That's where we're going to say the tangent function starts. So just like sine and cosine, they went to negative, they had a domain of negative infinity and positive infinity. Tangent will go to negative infinity and go to positive infinity. However, where we want to start is at negative pi halves. Sine and cosine, we always started at 0 for the generic function, and then we had a shift from there. So let's see how that applies to tangent. So if we want to graph one period of y equals tangent of x, this is where this will make a little bit more sense. So first I'm going to do the graph, then I'll label the domain, the range, the amplitude, and the period. So this is what you want to know for tangent. Notice that I'm still going to have 5 points or locations that I'm going to use. So that has not changed from our sine, cosine graphs. So I'm going to label these negative pi halves, negative pi fourths, 0, pi fourths, and pi halves. What is the tangent of negative pi halves? It is undefined, so that is an asymptote. What is the tangent of pi halves? Also undefined, so that is an asymptote. What is the tangent of 0? It is 0. What is the tangent of pi fourths? It is 1. What is the tangent of negative pi fourths? It is negative 1. And then I draw my curve. That's a horrible curve. I apologize. That's what the curve looks like. My bad. Anyway, so this is the image you want to have, just like with sine and cosine. You want to have what does one period of the function look like? You want to have that image ingrained or tattooed into your brain. So this is the image that you want for tangent. When we talk about 5 points that we plot, well, with tangent, we are going to plot 5 locations, but 2 of those locations are going to be asymptotes, the beginning of the period and the end of the period. Then we will have 3 points in between. So what is the amplitude? Trick question. None. Or maybe a better way to write that would be does not exist. Why does it not exist? What is our definition of amplitude? Great question. Definition of amplitude is half the distance of the range. What is the range of this function? Well, what did we just talk about? Domain of the inverse was negative infinity to infinity, and the domain of the inverse is the range of the function. Or the range of the function is the domain of the inverse, I should say. The range of this is negative infinity to infinity. I can't take half of negative infinity to infinity. That's still negative infinity to infinity. So the amplitude does not exist. Anytime you're dealing with a tangent function, that is your answer. There is an a value. The a value will affect the graph. We'll talk about that on the next slide. What is the period? The period is pi. The distance of one complete cycle, the distance from negative pi halves to pi halves, is a distance of pi. What is the domain? This is a little bit tricky. The domain, we're going to write, is all real numbers, except x does not equal, and then this is going to be one of the asymptotes, so I'm going to say negative pi halves plus n represents any integer, and then times the distance between asymptotes, which is pi. What is the range? We just talked about this. Negative infinity to infinity. That is the tangent curve. So, generically, amplitude does not exist. Vertical shift, it does exist, but we are not dealing with vertical shifts for what we're doing in this class, so we're going to say none. You can have a vertical shift with a tangent function, we aren't doing it. Period. Since the standard period is pi, now the period of any tangent function is pi over b. The intervals are still the period divided by 4. The starting x value, which is going to be an asymptote. This is different than the horizontal shift. So the starting x value, the first point you're going to plot, you're going to find by set bx minus c equal to negative pi halves, and then solve for x. Why are we setting it equal to negative pi halves? Because the standard tangent function, y equals tangent of x, has the first asymptote at negative pi halves. So again, this is the starting x value. It is not the horizontal shift. Tangent is the only unique one in that way. The vertical stretch, so this is still going to be your a value. So a will still affect the graph. Horizontal shift is still the same as before, however it's less useful with a tangent function, but we set bx minus c equal to 0, solve for x. Notice again here, this is the same as before. I showed you here we have b in the parentheses, here I have b factored out of the parentheses. So just as with the sine and the cosine, when I say set bx minus c equal to negative pi halves, or set bx minus c equal to 0, what I'm actually saying is set what is in the parentheses equal to negative pi halves or equal to 0. So what are our strategies for graphing tangent? Find the a value, find the period, and intervals, find starting x value. Notice I did not say horizontal shift. Draw, graph, and plot points. Alright, what do we mean? Let's graph y equals 1/4 tan of pi x over 4. So first I want you to find a, period, intervals, and the starting x value. Pause the video, do that, unpause when you're ready to check. Alright, so I have an a value of 1/4. That'll come into play when I draw my axis. The period is 4 because pi over 4 is 4. Therefore the intervals are 1. The starting x value, I set pi x over 4 equal to negative pi halves. Multiply by 4, divide by pi, I get x equals negative 2. So now let's graph. So I have negative 2, negative 1, 0, 1, 2. I'm going to call this 1/4, and this negative 1/4. So these values are how the a value is going to affect our graph. Now I just draw my picture. Asymptotes to begin and end the period. Put a point in the middle. A was positive, so I go up to the right, down to the left. And draw my curve. Bam. One period of the tangent function. Next one. So we are running out of time on this video since I only have 15 minutes on this lovely software. I want you to try to graph this, and then video 2 we'll discuss, or part 2 we'll discuss how to graph it if you get stuck.